Okay, let's unpack this. We're going to dive into the silent architecture of music today.
Right, the mathematical framework that organizes rhythm.
Exactly. When you listen to a drummer or even a full orchestra, everything sounds so cohesive. It's
Mm.
because they're all following this precise, predictable pattern.
And that structure is what keeps them all perfectly synchronized.
So what do we call that structure?
That is the time signature. It's essentially a set of instructions. You see it written at the very beginning of any piece of music, and it provides that foundational pulse.
And today we're focused specifically on simple time signatures.
Yes, the building blocks of rhythm. The best way to think about it is um, keeping a steady beat while you're walking. That even easy to follow pulse, that's the feeling we're talking about.
I always wonder about that word simple. Does that mean there's a complicated version?
Well, there is, and the distinction is really important. The main rule for any simple time signature is that the main beat, that pulse, it always divides cleanly into exactly two smaller equal parts.
So if you can split the beat in half, it's simple.
That's the core concept right there.
Yeah.
So our mission today is to take those two stacked numbers, the ones that look like a fraction, and really understand the rhythmic code they represent.
Okay, here's where the code analogy really clicks for me. You've got a top number and a bottom number.
Yeah.
They're like coordinates for the rhythm.
Mm-hmm.
The top number tells you how many main beats are inside one measure one rhythmic cycle.
And the bottom one.
That tells you what shape of note actually gets counted as one full beat.
Perfect. So let's decode that top number first, because that defines the entire meter.
The feel of the music.
Exactly, the feel or the character. In simple time, that top number is almost always going to be a 2, a 3, or a 4.
So if a composer picks two, what kind of feeling are they trying to create?
That's called the duple meter. It
Ah.
creates a very strong, weak pulse, like left, right, or a simple heartbeat.
Very energetic.
Very. It feels driving. Composers use it when they need that forward movement and intensity. You hear it all the time in military marches or fast polkas. It's all about momentum.
It sounds a little restrictive, though, only having two beats to work with.
It is, but that short cycle is what gives it its punch. Now, if the top number is a 3, you get triple meter.
And that shifts the feel completely.
Totally. Instead of a linear march, it feels circular, like it's spinning or swaying. You still get a strong accent on beat 1, but beats 2 and 3 are much lighter.
The waltz.
The classic example is the waltz. That's triple meter, defining that graceful, sweeping feel.
So 2 gives us momentum, 3 gives us flow, then 4 must be the default setting.
4 is the heavyweight champion, for sure. Quadruple meter. It is by far the most common pattern in modern music because it just feels so stable and balanced.
How are their accents different?
Well, the strong accent is on beat 1, but it also has this secondary, slightly softer accent on beat 3. So it goes strong, weak, medium, weak.
Ah, okay. That internal symmetry gives it a really wide base, doesn't it? Makes it easy to layer other things on top.
That's exactly why it works for everything from pop songs to symphonies.
Mm-hmm.
And crucially, that top number is what tells you where to put the bar line.
It tells the musician when to reset the count.
It's the traffic cop of the music. Okay, so now let's tackle the bottom number. This is the one that often trips people up because it feels like pure math.
And it kind of is, right? It's a code representing the note value.
It's a code, but it's simpler than it looks.
Yeah.
The easiest one to read is when you see a 4 on the bottom. In music math, that number 4 just stands for a quarter note.
So 44 time literally means 4 quarter notes in a measure.
You got it. The quarter note gets one full beat.
But composers don't always use the quarter note for the main pulse.
No. And that's the really brilliant part of the system. If the bottom number is a 2, that represents a half note. So now the half note gets one beat. If it's an 8, the quick little eighth note gets one full beat.
But wait, why would you bother changing that? If the music speed is basically the same, why not just write everything in 44?
That's the key question. Changing the bottom number lets the composer change how the music looks on the page without changing how fast it actually sounds.
Okay, give me an example.
Imagine a really, really fast piece. Let's say every beat is made up of 16th notes. If you wrote that in 44, the page would be just black with ink. So many tiny notes and flags. It'd be a nightmare to read at speed.
It would look incredibly messy.
Right. But what if the composer writes it in 48 time instead? Now those fast eighth notes just look like simple quarter notes on the page.
Ah, it cleans up the sheet music.
Instantly. It makes a really difficult rhythm look visually clear so the musician can process it faster.
Yeah.
It's a huge practical tool for readability.
So the bottom number is for clarity, making sure the code is easy to read. Okay, let's apply this to the music we hear every day, starting with the big one, 44.
It's literally nicknamed common time.
Because it's everywhere.
It's so pervasive.
Yeah.
4/4 note beats in every measure. And sometimes you won't even see the numbers 44. You'll just see a big capital letter C.
Why?
It's a historical thing. It used to be considered perfect time and was shown with a full circle. When triple time was more popular, it was marked with a broken circle. Over time, that full circle just got simplified to the C for common time.
And it's still the anchor for almost all rock and pop music.
It is. That balanced strong medium accent structure is just a reliable foundation to build on.
Okay, let's pivot to the duple meter examples. Talk about 24. How does that compare to 44?
They both can feel march-like, but 24 is just way more intense. It forces this immediate repetition. 2 beats, quarter note gets the pulse. A musician is just constantly counting 1, 2, 1, 2.
It keeps that urgent driving momentum going.
Exactly. The measures are short, the phrase turns over really quickly, and you can pack a lot of fast notes in there to really drive home that feeling of energy.
It's the difference between a brisk walk and a full-on jog.
That's a great way to put it.
Yeah.
And then you have the elegant 34, the triple meter. This is the signature for graceful, flowing music, holiday songs, folk dances.
It has that down-up-up feeling. Strong beat 1, then 2 light beats.
Right. And that creates a real performance challenge.
I can see that. It must be so tempting to rush through that weak third beat just to get back to the strong one.
That is the #1 challenge of playing in 34 time. You have to be so precise and hold that third beat for its full value, otherwise the music speeds up and gets all jerky,
The goal is to make it feel seamless and swaying.
which requires a lot of control.
And to get that precision, you really need to understand the visual structure that guides you. Let's talk about the bar lines.
Okay, so bar lines are the vertical lines you see cutting across the staff. They're the visual boundary markers for the time signature.
They're not just random dividers.
Not at all. They're stress markers. They show you exactly where one rhythmic cycle ends and the next accented beat begins.
And the fundamental rule is that the math inside that space has to add up perfectly.
It has to. If the time signature is 34, then all the notes in that measure, whether it's 1/2 note and a quarter note or 6/8 notes, they have to add up to exactly 3/4 notes worth of time. The measure has to balance.
And there are different kinds of bar lines, too.
Right, a single bar line just separates measures. A double bar line means there's a new section coming up. And that thick, final double bar line at the end tells you, stop, the piece is over.
So structure is the foundation, but precision, that's the skill. Which brings us to subdivision. This feels like the secret to perfect timing.
It really is. Subdivision is the mental and sometimes physical act of breaking down that main beat into its smaller equal parts.
And since we're in simple time, the beat always divides into
2 equal halves. A quarter note splits into 2 eighth notes.
Yeah.
It's always in 2.
How does a performer actually use this? Especially when the music is fast.
You count it. Instead of just counting 1, 2, 3, 4, you actively count the subdivisions. You say 1 and 2 and 3 and 4 and.
So you're voicing the space in between the beats.
Exactly. By always thinking about that and, you're making sure any notes that fall there, like eighth notes, are placed perfectly halfway through the beat. They're not rushed, they're not delayed.
So even if I'm just playing a simple passage of quarter notes, I should still be mentally thinking 1 and 2 and.
Absolutely. You use that finer grid to check the placement of the bigger notes. It's what allows a musician to play with near-perfect accuracy. So every note starts at the exact millisecond the composer wanted it to.
It sounds like the best way to fix a tricky rhythm.
It is. Slow it down and count the full subdivision out loud. It's the fastest way to solve the problem.
Of course, this all requires a solid grasp of the musical math of note values, the shapes themselves.
Right, the circles and stems. You have to use those shapes to fit inside the measure. In 44 time, a whole note fills all 4 beats. A half note lasts for 2, a quarter note for 1.
And then the subdivisions.
The eighth note lasts for half a beat, and the 16th note for a quarter of a beat. Just basic addition to make sure you never breach those measure boundaries.
Now we have to make a crucial distinction that can confuse people. The difference between the rhythmic pattern and the actual speed.
Yes. The pattern is the time signature. The speed is the tempo.
Okay, explain that.
Tempo is just how fast the beats are happening. It's measured in beats per minute, or BPM. The time signature, say 44, that's like the distance of a race. It's fixed.
And the tempo is how fast the runner is going.
Perfect analogy. You can run that same 44 race at a slow crawl, maybe 60 BPM, or you can run it at a full sprint, like 140 BPM.
The pattern stays the same, 4 beats are still in the measure, but the emotional impact changes completely.
Completely. The composer sets the pattern with the time signature, but they set the mood and the speed with the tempo marking. Understanding that relationship is vital.
This has been a great deep dive into the real architecture of music. It's clear that simple time signatures are just. They're everywhere. From the stable 44 in pop music, to the driving 24 of marches, to that 34 sway in holiday tunes.
They are absolutely the foundation. Once you master this idea, the two-part division, the top numbers meter, the bottom numbers code, you have the tools to analyze almost any music you hear.
So what's a good next step?
Try this tonight. Put on your favorite song, and instead of just listening, start tapping your foot. Try to count the strong accents and see if you can figure out the time signature just by feel.
Understanding this musical math really does make you a more insightful performer and a much better listener.
It really does.
Good luck with your studies.